Hey, fourth grade. Today is Wednesday, November 4th, 2020, which means we are switching over to our November Number Corner calendar. This month's calendar pattern focuses on skills and concepts related to telling time and calculating elapsed time. Today, we are going to fill out our calendar grid observations for cards 1 through 4. But before we do that, I want to make sure we all know what elapsed time is. Elapsed time is the amount of time that passes between 2 points in time. We're going to watch an example to better understand what elapsed time means. Follow along as Mia describes her problem.
Mia is a total speed demon and runs second in the 4x800 meter relay team for track. She started her lap at 2 minutes 42 seconds. She handed her baton off at 4 minutes 59 seconds. How fast did she run her lap? First, identify the bigger number. Since the finish time number is bigger, it'll have to go on top. Next, write down the smaller number. The start time is smaller, so that'll go on bottom. Subtract the times to find out the elapsed time. 4 minutes and 59 seconds minus 2 minutes and 42 seconds is 2 minutes 17 seconds. That's our elapsed time. So Mia is pretty speedy. She ran her 800 meters in 2 minutes and 17 seconds.
All right, we're going to watch one more video so we can better understand elapsed time. This video is great because it shows how we use elapsed time in real life.
I know, but Mom gave us strict orders to be home by 6 o'clock sharp for dinner. Well, the movie is an hour and 35 minutes long. If we figure out exactly what time the movie lets out, we'll know whether we can make it home in time. Dear Tim and Moby, what is elapsed time? From Towson. Elapsed time is the amount of time that elapses or passes from the start of an activity to the end. Knowing how to solve elapsed time problems is important for making plans, like catching a cool new sci-fi action flick. It's also an important part of time management in general. Like if you crawl out of bed at 7:35 and school starts at 8, you'll know how much time you have to get ready. Well, your days of tardiness are numbered, my friend. There are tons of ways to solve elapsed time problems, but we'll stick with two: the cutout clock with movable hands and the T-chart. Don't worry, you'll get it after we try a few examples. First, let's figure out when Time Twisters is really going to start. It says it's starting at 3:10, but we know there will be about 15 minutes of previews and commercials first. So, what time will the movie really start? Let's use the T-chart for this one. We write the starting time above the left column and minutes above the right column. We know previews take 15 minutes, so we fill the right column with 5-minute intervals until we total 15. Then we add 5 minutes at a time to the start time. The time we get when we catch up to the right column is our answer. Okay, let's try another one with the clock. We took the 2:20 bus and got to the movie theater at 2:55. How long did the bus ride last? To the clock. First, we set the hands to the starting time. Then we move the minute hand 5 minutes at a time, counting as we move to the finish time. 5, 10, 15, 20, 25, 30, and 35 minutes. And that's how long the bus ride lasted. Right, the T-chart and the clock both use the same basic strategy. Take the starting time, then add minutes in bite-sized chunks until you reach the ending time. This way, the strategy also works for larger units of time, like days, weeks, months, and years. So we can calculate how many days we'd have to wait if we want to see the movie next Tuesday, or what year it'll be when Time Twisters 2, the sequel, comes out 3 years from now. Exactly. Use the same T-chart, but just replace minutes with days or years. or swap out the clock for a calendar. But that's a problem for another time. Back to minutes and hours. Let's use both the clock and the T-chart for something that lasts longer than an hour, like the 3:10 showing of time twisters. We simply tackle the hours first, then the minutes. First, remember we already figured out that after the previews, the movie won't start until 3:25. The movie is 1 hour and 35 minutes long, so let's add that hour first. Then let's add 35 minutes, 5, 10, 15, 20, 25, 30, and 35. Since the minute hand has made a full circle on the clock, we advance the hour 1 more hour. And there you have it, the movie ends at exactly 5 o'clock. We'll confirm that by drawing 2 T-charts, one for hours and one for minutes. Starting with hours, we add 1 to each column. That gets us to 4:25, which we plug into the second chart as our new starting time. Now we can add minutes by 5. There you have it. We'll be out of time twisters at 5 o'clock with an hour to spare before dinner. Right, even with a 35-minute bus ride, we'll definitely make it home in time. Of course, that assumes the bus doesn't take 3 days to get here.
All right, when we're telling time and showing elapsed time, it's also important to remember what AM and PM stand for. AM stands for ante-meridium, which means before midday, noon, and PM stands for post-meridium, which means after midday. The 12-hour clock was developed as early as 1500 BCE, before Common Era, and was used in Egypt, Mesopotamia, and Rome. Let's fill out our calendar grid observations chart for days 3 and 4. Days 1 and 2 are already done for us. If we look at each marker for days 1, 2, 3, and 4, we are going to first tell the time. So on days 1 and 2, we see we have 12 o'clock and 1:10. Take a look at the background image. What do you notice about the background? Do you think this is PM or AM? Well, it looks like it's nighttime. But when it's nighttime and it's 12 o'clock, we actually say that's 12 o'clock AM. So we are in AM right now. Take a look at card number 3. Card number 3's time is 2:20. So we are going to write our date, the time 2:20, and since we're in the middle of the night, it is AM. Now, between the times 1:10 and 2:20, between today and the day before, it is an hour and 10 minutes. Okay. Now our last column is the total time elapsed since the first. So if we look at the first, it was 12 o'clock AM, and now it's 2:20 AM. So the total time elapsed since the first is 2 hours and 20 minutes. Now for card number 4, which is for today, if we look at that clock, it reads 3:30. We're still in the middle of the night, so it is AM. Between 2:20 and 3:30 AM, 1 hour and 10 minutes have passed. And between 12 o'clock AM and 3:30 AM, 3 hours and 30 minutes have passed. We'll continue filling out this chart and noticing the patterns. Start thinking about what patterns you already noticed. Today your job is to complete page 23 in your Number Corner book. Page 23 has you take a look at 10 markers from the calendar grid. You're going to write the time under each clock and be sure to show whether it is AM or PM. Remember that midnight is AM and noon is PM. The first 2 have been done for you. After you fill in those clocks, number 2 asks you how much time has passed between clocks A and B above. What is the elapsed time between those 2 clocks? And number 3 asks you how much time has passed between clocks E and F above. What is the elapsed time between clocks E and F? If you need help, please message me on Schoology.